And interestingly, you're gonna write if I don't hear you. And I don't hear you. Oh, okay, okay, because I didn't turn it on. I'm sorry. Can you speak now?
Can you hear us?
Can you speak now? Okay, okay, I'm sorry. I turned it on because of some noises. Okay, during the break. Sorry, it's my bad. Oh my God. Anyways, now we continue. Okay, have you seen Wolfram Alpha before? No, probably, right? I put it in here. So why is Wolfram Alpha good? Because you can write just, I wrote this right now, okay? I wrote this during the break. So you can enter what you want to calculate or know about. So I just wrote draw y is equal to 2 to the x and y is equal to logarithm 2 base 2x. And I just click on enter. When I do that, it's going to give me the function. It is good because it's gonna teach you, you will be able to double check that whether the graph that you draw is right or not. Okay? Okay, it comes up here. Look, it says plot y is equal to 2 to the x, plot y is equal to logarithm base 2x. All right? So the blue one is, I'm not sure whether I can enlarge this, and I'm not sure you can see it. Can you see it, guys? Let me make it enlarge. I will try to enlarge that if I can. Okay, now I was able to do that. All right, look at that. The blue one, this blue one is e to the x, 2 to the x. And this pink one, just ignore the one on the left, the pink on the left, because it's, this is the one that we are interested, logarithm base 2x, okay, this one. All right. Do you see that these two blue and this pink are symmetric with respect to the y is equal to x here? If you draw a y is equal to x line here, it is symmetric. So this is going to tell us that these two functions are inverses of each other, okay? All right, so this is Wolfram Alpha is good. And sometimes we are going to do that, okay? It's very useful. And I put it in there if you need it, okay? All right, let's go back to where we left off. Okay, Hatice is saying something. Go ahead, Hatice.
Hocam, ben bir şey yazamıyorum.
Nasıl Hatice?
Hocam Ceren ismim. Chat'e bir şey yazamıyorum ben.
Onu Teams'in web sayfasına girip işte chat'e neden yazamıyorum, İngilizce yazsanız, search etseniz o tür hataların neden olduğunu öğrenebilirsiniz ve çözümünü de bulabilirsiniz sanki.
Ekip üyesi olarak görünmüyorum. Derse ilk girdiğimde ama üye olarak görünüyordum ve yazabiliyordum. Şu an yazamıyorum.
Okey. Siz o zaman member olarak tekrar eklemeye deneyelim. Hatice Ceren değil mi?
Evet, Ceren Hatice.
Ceren Hatice, okey. Şimdi birkaç kişi daha gelmiş. Ben eklemeye çalışacağım şimdi hemen. Bir saniye. Evet, member. Başka eklenmek isteyen varsa söylesin. Is there anyone who wants to be added to the team? I can add it now. Okay, here you are. Okay, anybody else who want me to add them to the list?
Adil Keleş Temur diyeceğim.
Adil Keleş Temur. Adil Keleş Temur. Okay, let's see. Come up here. You can see my screen, do you?
Yes.
Adil Keleş Temur, right? Timur mu, Temur mu?
Not separated, teacher. You can see my name now.
Mehmet Ali. Okay, I see. I got you. Okay, anybody else? Any other names? Okay, I think that's it. It just takes forever. Let's see, just a second. Oh, Mehmet Ali, there's a problem. Maybe you registered before because it gives an error. Okay, let me see. I'm gonna close this part. It just gives an error with your name, under your name, for some reason. Mehmet Adil Keleştemir, doğru mu?
Yes, true.
Okay. Okay. Okay. All right.
Also,
Okay, maybe
Mr. Meyer,
yeah. Go ahead.
I'm added to Math II.mp4 class 2. I have two teams, two groups, which is Math 101. So can you remove me from the 101 to Math 101 too?
Okay. Okay. Section 2, you shouldn't be there, right?
Mhm.
Okay. All right. I will do that later, I think,
Okay.
because I don't know how to remove. I have to learn first, okay? So if you send me an email to remind me, I will do that, okay, later.
Okay.
Okay. Thank you. Let me get out of here. Okay. So we were talking about inverse functions, right? So for example, logarithm and exponential are inverse of each other. Let's do another Wolfram alpha. Do you know any other functions that are inverse of each other, or is there any function that you're interested in finding the inverse of? Can you give me a function name? Give me a function. For example, y is equal to what? Cosine x. Okay. And what is the inverse of y is equal to cosine x, by the way, right? Draw this and inverse of that. Cosine x inverse. Let's write it like that. The inverse of that is arc cosine. You're going to hear it later on, okay? So I'm writing it now so that your ears are getting used to it. Okay? So these are inverse of each other. Let's look at the picture. I'm just, I hope it's going to draw this.
Same break that New's grandmother had. There was a pet shop.
Okay. So if you look at this graph, look at it. I want you to just look at between 0 and 2. Okay? I don't want you to look at anywhere else. Okay? Because cosine and arc cosine, they have just restrictions. They cannot be inverse of each other everywhere. They can be inverse of each other just on an interval. Okay? So look at this y is equal to x line. Look at this y is equal to x line. See, the pink one and the blue one are symmetric with respect to that. I just want you to see the symmetry. Okay, if you draw a line here, y is equal to x, and blue and green, our blue one is the cosine, pink one is the arc cosine, this is arc cosine, the inverse of cosine, and they are inverse of each other and they are symmetric, okay? And another example, y is equal to, all right, so I'm gonna give you this. Okay, just a sec, I'm running out of battery again. Let me put it in.
Teacher, do you speak?
Can you hear me? I'm sorry. It's my bad. Okay, so I turned it on. Thank you for reminding me. So I want to show you another two functions that are inverses of each other. This is a line and this is a line too. These are inverses of each other. Okay, let's see the graph of those. Okay, look at that. If you draw, see, this is not perfect. Look, this is 5 here, this is 5. So actually, if you draw the correct distances between, see, this is 1 here, this is 5. Can you see it? So this is not really the best picture in terms of the, okay, scales. Scales are not the best. So if you draw a line here, okay, well, maybe I can change the scales. Let me change the scales if I can. Let me do that. -2 to negative, maybe -10 to -10 to 10, right? -10 to -10 to 10. Okay, I want this to be drawn on -10 to 10. Let's see how it's gonna look, because I want you to see the symmetry. Okay, that's what I'm trying to do.
Teacher,
It's gonna come up. Go ahead.
could you please explain
Go ahead.
how can we draw the graph from the function? Because until now I don't know how.
I mean, by hand, do you mean?
Yes, by hand or other ones, no problem.
Uh-huh.
I mean, how
on
did
Wolfram
we
Alpha,
get? I mean, how did we
the inverse?
get this graph from that function?
Yeah, this graph. Okay, that's a good question. Drawing a line. Okay, drawing a line is easy in the sense that you just need to find 2 points on here. For example, let's try to draw y is equal to 3x plus 2. Let me go back to our. You're not asking about Wolfram Alpha, right? You're asking about in general by hand.
Yes.
Okay. Okay. So drawing is, for example, you are interested in drawing these guys. Okay. So how do we draw? Let's just look at the exponential function that we just discussed, or let's start from there. So what you do is, okay, how would you draw this exponential function by hand? You just need to know, okay, let's write it here, okay, how to draw by hand. I'm going to write that here. Okay, how to draw, let's change the size. Okay. Okay. How to draw by hand? That's a good question. Okay. Okay, that's a good question. And here's how you would do. For example, let's learn how to draw this exponential function by hand. Okay. Okay. So first thing that you're gonna do, you should know some facts about these exponential functions. You should know that if the base is positive, it's gonna go up like this. And if the base is bigger than 1, I'm sorry, if the base is bigger than 1, it's gonna go up like this. And if a base is less than 1, it's gonna go down like this. You should know this fact first, okay? Next, what you do is find, okay, 2 points. 2 points on the graph. Let me give you explicit example. Okay, draw the graph of example. Draw the graph of y is equal to 2 to the x. Okay, let's try to draw that. Solution. Okay, find 2 points. Find 2 points on the graph of. For 2 points on the graph, we say. How? Okay, for example, I'm gonna let, you can choose any x, let x is equal to 0, and put it in. Okay, then 2 to the 0 is equal to 1. So we have a pair. Point P1 is our first point, and the x value is 0, and the y value is 1. Okay, this is a point. Okay, is a point on the graph. This is the first graph. This is the first point, and I'm going to choose another point. Okay, let's okay, let me copy this down, and then let our second point P2, okay, is going to be, let's x is equal to be 1. Okay, then 2 to the 1 is 2. Okay, and 1 to 2 is another point. Is another point. Is another point on the graph. So I have two graphs. So what I'm going to do is I'm going to plot them on the xy coordinate plane, and then I'm going to, and I know the fact that 2 is greater than 1. Look, the base. Where's that? Where's my base? Okay, let's go up. The base is 2. 2 is bigger than 1, and I know this has to be increasing function, and it should look like this. So I'm going to plot my 1, and for x is equal to 1, I'm going to plot my 2 here somewhere. Actually, it's here, right? The graph is in here. Look, for x is equal to 2, it is 1. For x is equal to 1, it is 2. I'm going to just combine the 2, and I know the rest is going to go up. And before 0, it's going to go down like this. And that's a good point. That's a good picture. You don't have to do anything else. Okay? Just find 2 points and be aware that this function is going to be like either in this form or this form, and just draw it that much. That much is good enough for us. Just show 2 points on the graph and combine them, and you're good to go. Okay? Similarly, do you want another example for this, for exponential? Is this clear?
Maybe one more example.
Okay, one more. Let me give you another one. I'm going to give you another one like this. I'm going to copy paste just to save some time. Okay. All right. So let's go up. Draw the graph of y is equal to, I'm going to do that. Look, 1 over 3. 1 over 3 to raise it, 1 over 3, raise it to the power x. Okay. Okay. How would you draw the graph of that? The solution says find 2 points on the graph. So I'm going to give numbers. So let's let x to be a -1 for a change. And the base is what? Base is 1 over 3, right? 1 over 3. Okay. 1 over 2, raise it to the power -1. Okay, what is this equal to? Can you tell me? Can you guys tell me 1 over 3 raised it to the power -1? What is this equal to?
3.
This is 3. That's right. That's right. So this tells me that I have the first point, which is P1. It is -1 to 3, right? It's my first point on the graph. And then I'm going to find another one. Let's use x is equal to 1 again. And then I'm going to copy paste this if you like. Okay, to make it easier for myself. 1 over 3, raise it to the power 1. And it's going to be nothing but 1 over 3 again. So, okay, I got that. And then I have 2 points now. 1 to 1 over 3. Okay, 1 over 3. Okay, I have this another point. So what I'm going to do, I'm going to take P1 and P2 and plug it, put it on my xy coordinate plane. Okay, P1 is -1 to 3. -1 to 3. It is this point actually. Okay. And then the other point is x is equal to 1, which is this. 1 to 1 over 3. It is this point. I'm talking about big picture. So I'm going to just combine them curved like that. Curved. Because I know exponential functions has the graph curved. They're not straight. And then just, since I know it is decreasing, I can just make this size a little bit longer. And this very long and get close to 0. Never touches the x-axis. And that's my picture. Okay, that's how you would draw the graph. Okay, how about logarithmic functions? Okay, how would you draw them? Okay, let's do that. Okay, I'm going to close this. I think I copy pasted. Let's see. And I'm going to do a similar thing for logarithmic functions. And the idea is the same. Look, let me close this. Okay. Just one sec. Let me just one sec. Okay, sorry about that. So I'm back with you here. So what you're gonna do is we are gonna comment on this. Okay, copy paste because I'm gonna change that to logarithmic functions here. Okay, so the question is the same: how to draw by hand the logarithmic functions, right? So let me put it up here. Draw the graph of, for example, logarithm. What do we have here? Logarithm base 3x. Okay, what's the solution? Solution is find 2 points on the graph again. The same idea. So for example, x is equal to 0 is not acceptable because 0 is not defined. For logarithmic functions, x is equal to 0 is not well defined. So you can choose, for example, x is equal to 1 over 2. 1 over 2. And what is this then? Let's copy this down. Okay. Okay, logarithm base this 1 over 2. 1 over 2. Okay. This one you need to find a calculator. And this is approximately, let me see from here. We are doing this. It is going to be like negative 0.5-ish. Something like that. Okay. Negative approximately. I'm just guessing. Okay. You can just find it by using a calculator. Okay. This is close to that number. And then I have this for 1 over 2. I have this number, negative 0.5, approximately, of course, negative 0.5. This is approximately. Let me write that because it's not, it may not be exactly, approximately. Okay. It's a point on the graph, and then I'm going to choose another one. I can choose something like, for example, 9. Okay. X is equal to 9. Whenever x is equal to 9, I have, so I'm going to erase this. So this is going to be 9 is what? 9 is 3 squared. Okay. This is good. For the logarithmic functions, we have such a rule. So if this is 3 raised to the second power, this is the same as 2 times. Okay, let me copy that. This is a rule for the logarithmic function properties, which you have seen in high school. Okay, and logarithm base 3 to 3 is 1, so this is 2 times 1 is 2. Okay, whenever x is 1, whenever, let's see, whenever x is 9, whenever x is somewhere up here, the value is 2, so it should be somewhere up here. Okay, so the pink one is going to continue like this. So you're going to combine this point with this point here, and you're going to combine it like a curve here, but it has to also go through 1. This is very important. Make sure that it goes through 1. Okay, draw a curved line, draw a curve passing through these 2 points, P1 and P2. This should be P2, yeah. Where's my P2 though? Just a sec. Let me write P2, copy paste, just a sec. P2, yeah. P2 is here. For some reason, I didn't write my P2 here. P2 is a 9 to 2. 9 to 2, yeah. This is the point passing through. Is another point. Is another point on the graph. Okay. Draw a curve passing through x is equal to 1 and P1 and P2. P1 and P2. Make sure that it passes through x is equal to 1 as well. Okay, because all of them is going to go through that. And then you get the picture. Okay? That's how you get the graph of logarithmic functions as well. You choose 2 points and make sure that, let me erase this one because this we don't want that. You want to pass through 1, you need 2 points plus this point 1, and then combine them in a curved way, and you get the logarithmic function graph. Okay, that's how you do that. Okay, so any questions? Did you get that? Or is this clear? Can you follow that?
No problem.
Okay. Is this no problem? Did I hear you right?
Yeah.
Okay, perfect. Good to hear. Okay, so if you have any questions, you can ask me anytime. Okay, so let's move on. So I want you to see this picture. This is a graph. Look at this graph, okay? Of course, this is an expression as well, but they call it, this is a special graph probably, so they give a name. They call it graph of a catenary or hanging cable. Look at it, it's like a hanging cable between two towers, right? So probably this is a special function that's used, even if this looks simple. This is used somewhere that's useful. Therefore, they give a special name. Okay? All right, let's move on. Section 1.2, combining functions, shifting and scaling graphs. Okay, so what do we see here in this picture, in this page? You can see the graphs, functions f and g, and their addition of the two, difference of the two, and product of the two, ratio of the two in different orders. Okay. Here's an example. If your f is square root of x and if your g is square root of 1 minus x, you add them up like this. The difference is like that. And you can change the order g minus f. You have to shift the order of these two. And the product of the two is just square root of 1 and then square root of the other. You can combine them in one square root. And look at the domain. Look at the domain. The domain, so when you are combining the functions, no problem. It's easy to combine them. Look, multiplication is easy. Taking the ratio is easy. Just write the square root of x over 1 minus x. If you just do g over f, it's just square root of 1 minus x over x. So the formulation is good. But the domain is a little bit tricky. Okay? When you're combining, so what does it mean? We are creating new functions using two functions. Okay? You can always create new functions by using two functions. We did this before actually, remember. So for example, we said that's 2 to the x function and let's shift it to the right and we get a new function, x plus 2, 2 to the x plus 6 or something, right? So you can always create another function from the function that we start with by just either shifting, adding some numbers to x or adding some numbers to y, or maybe you can use a couple of functions together, adding them up, and you get a new function. You are free to do that. But when you're doing that, you have to be careful about the domain. So if you are doing an addition or subtraction, the domain is going to be the intersection of the domains. So for example, what is the domain of square root of x? Let's write it here. Okay, what's the domain? Let's write. Okay, can anyone tell me domain of square root of x? Okay. Can anyone remind me that? Domain of square root of x. Not writing. Okay, just a second. D of square root of x. What's the square root of domain of square root of x? D means domain. All non-negative reals, right? All non-negative reals. Okay. What does it mean? All reals bigger than 0. That's what it means. Okay. Okay, what's the domain of, on the other hand, square root of 1 minus x? Okay, square root of 1 minus x. Okay, is this still all negative, non-negative reals? Can anyone say? Is it true? Is this true? Yes or no? This is not true. Not true. Okay, so the domain of this has to be, how do we find it? We have to find it like this: 1 minus x is greater or equal to 0, right? This is not equal. Okay, that's how we find it. So this is going to tell us that x has to be, namely, x has to be less than or equal to, right? Less or equal to 1. Okay, this is the domain. So the domain is everything less than or equal. Okay, everything less than or equal to, everything less than or equal to 1. Equal to 1. Okay, so square root has the domain all non-negative reals. Square root of 1 minus x is everything less than or equal to 1. But how about if we add them up? What's the domain of the addition of the two? Okay, what's the domain of, okay, domain of this, I mean square root of, just a sec, we have to add them up. Okay, this plus that. Okay, what's the square root domain of the sum of the two functions? It is the intersection of the two. So this is all, I mean, all non-negative reals. What does it mean? X is greater or equal to 0. X is greater or equal to 0. That's what it means. Okay. And the domain of this is, what does it mean? Let's write it here. Okay. Let me write it down here. X is less than or equal to. Okay, less than or equal to 1. Yeah. So what's the intersection of this and this? Actually, the domain of this is, the intersection is, so real numbers bigger than 0, real numbers less than 1, they have the intersection of what? Real numbers between 0 and 1. Okay, so the answer is between 0 and 1. Okay, so the difficulty here, when you have two functions in the picture, the domains are not the same domains anymore. I mean, the new function that you get is, the domain is going to be the intersection of the domains. That's what it means here. Okay, so you have to be careful. So in the subtraction as well, you have to be careful. In the subtraction, it's going to be the same, 0, 1. In the product of the two, you have to just take the intersection of the two. But when you get to the ratio of the two functions, okay, like this one, let's see. Okay, if this is the case, then you have to be super careful. So it's going to be the intersection of the two domains. However, you have to also exclude the points that makes the denominator 0. So therefore, we just first say that this is okay, but we have to exclude 1 because 1 makes the denominator 0. Similarly here, we are going to say numbers between 0 and 1, but we have to exclude 0 because 0 makes the denominator undefined. Yeah, so you have to, that's the difference. So whenever you have combination of these functions, then the domains are expressed like that. You have to, the only thing that you have to be very careful is f over g or g over f. Okay, all right, so that's it. Any questions on this page?
No.
Okay, wonderful. Now, if we add them graphically, how do they look? That's the picture. Let's say we have G here, we have the blue one F, the yellow one G. If we add them up, see, this is positive, it is getting bigger, and it's on top of the 2. Okay, similarly like that, because the function f and g are positive here, so the pink one, which is the sum, is going to be high above them. Okay, that's the picture you can see. In just keep it in your minds. Okay, there's another function here. Here it says the domain of the function f plus g is the intersection of the domains of f and g, the interval 0, 1 on the axis where domains overlap. Yeah, this interval is also the domain of f times g. Look, f plus g, the functions we just discussed, okay, their domain was 0 to 1. F times g has the same domain, okay? We are not talking about f over g or g over f, okay? So this is our f, this is our g, this is our f, this is the fishing rod. If you remember, the square root of x, we called it fishing rod. One of the students told me that, right? This is a fishing rod example, but this is the other way around fishing rod, square root of 1 minus x. If you add them up, you get a function like this. If you multiply the two, the graph is going to be looking like this, still on the same domain. Okay, that's just showing it. Okay, we can also draw the graphs of these on Wolfram Alpha. Okay, on Wolfram Alpha, you can easily ask to do that, and it's going to give you that. Okay, all right. Okay, so in high school, you have seen composition of two functions. If you have two functions, then if you compose them, okay, you get a new function, of course. When you compose them, you have to be careful though. The domain of f composed g consists of the numbers x in the domain of g for which g of x lies in the domain of f. So, for example, g has a range. The range has to be the domain in the domain of f. So, in order to make this reasonable, to make this work, okay, there's a detail, okay, in the composition of two functions. You can see it in the picture too. So, if we have g, x goes through g and to gx, the image. And then we apply f to the g. In other words, it's the image of g. We apply it, so we get f composed g like that. Okay. And then if you look at this picture, this is another picture. These are sets. So we have this is the domain of g, and then it's going to go to the range of g, and then range of g is the domain of f. Or domain of f is inside the range of g, I should say. So we have the image of f composed g, and see at the very end we have this red direction line. So x goes to f composed g like that. Okay. Okay. So let's see. Let's continue here. So now we are going to see some parabolas. Okay. So I told you before, right? Shifting up and down. So you're seeing shifting up and down. You know the blue one. The blue one is our well-known y is equal to x squared. By using this y is equal to x squared, we can create new functions. Okay, I'm just adding 1 to it. That would mean shift this blue one by 1 units up. I'm adding 2 units to x squared, and I'm shifting blue one by 2 units up. If you subtract 2 from x squared, you get a graph shifting down by 2 units, all right? So you can play with it like that. So you're creating new functions by shifting up and down. And similarly, we talked about shifting to the right or to the left. And we have this blue one, which is our original y is equal to x squared function that we used. We learned at the beginning of this class last week. And if you just subtract 2 from x, okay, from x, if you change the x and subtract 2 from it, that would mean you get the pink graph. You shift the blue graph to the right by 2 units. But if you add 3 to x here, you would shift the blue graph to the left by 3 units, okay? This is true for any function. It's not just parabola. Any function would work the same way. All right. Okay, our famous absolute value function are well known, and we really like the absolute value function a lot. Okay, so if you look at this function, we had 2 operations done on absolute value of x. First of all, it is shifted to the right by 2 units. Look, our V shape is shifted to the right by 2 units, and then we shifted towards bottom, okay, to down, shifted down by 1 unit. Look, then we get this picture from the graph of the absolute value of x. Can you see that? Is this clear? Okay. Is this clear, or do you want me to write something here? Can you follow? Let me do some additions here. Do you have any questions in the shifting and up or down to the right? So we do the shifting twice, okay? Here to get this function. This is a new function we got from this, okay? All right, so this is the summary of shifting vertical and horizontal scaling and reflecting formulas. This is a little bit something that we didn't really talk as much. So this is a new thing for you. We talked about vertical shifting up and down, horizontal shifting and up to the right and left, but this is horizontal, vertical and horizontal scaling. Scaling means you're making it bigger, thinner, wider, stretching, okay? Taking the reflection. Reflecting means you're taking the reflection of the graph. So these type of nice features. So for example, we are gonna have a fixed constant c that's bigger than 1, and now we are going to scale our graph by using this c. So if you multiply the function by c that's bigger than 1, it's gonna stretch the graph vertically by a factor of c. Okay, I'm gonna show you the pictures. If you, on the other hand, if c is bigger than 1, and if you are multiplying f with 1 over c, that would tell us that it's going to do what? Compresses. It's going to compress. It's going to make it thinner, okay? Or compress the graph vertically. Compress vertically means it's going to get wider actually by a factor of c. And then if you do this thing, if you multiply x by this constant factor c, it's going to compress the graph of f horizontally by a factor of c. I'm going to tell you what these mean. And then on the other hand, if you divide x by c, since c is bigger than 1, it's going to stretch the graph of f horizontally by a factor of c. These are a little bit complicated than what we just learned. Yeah, what happens when c is -1? We get a reflection. So let's say if we have y is equal to f of x and we just multiply with -1, it's going to reflect the graph of f across the x-axis because you're getting negative values for y. So anything on top of x coordinate, x-axis, it's going to go down backwards. Okay, it's going to take the negative values. So it's going to be a reflection across the x-axis. But if you do this for x, if you multiply x with -1, so it's going to be a reflection of the graph across the y-axis. You get the reflection. Okay, let's see some examples. Okay, so this is our fishing rod function. You remember fishing rod function, square root of x. So we are going to multiply the square root of x with a constant c bigger than 1, which is 3. If you do that, look at that graph. The graph is stretched upwards, okay, by 3 units. Look, for example, when x is equal to 1, this would take the value 1, but when x is equal to 1, the new graph is going to take the value 3. So it is shifted vertically by 3 units. Okay, if you multiply the square root of x with 1 over 3, it's going to compress it. So whenever x is 1, it's going to go to 1 over 3, the y value. Okay, it's compressing and stretching. Okay, vertical stretching, vertical compressing. Okay, if you do that. All right, let's move on. Again, our fishing rod example, square root of x. This time, if you do any changes to x, if you multiply x by 3, so you are going to compress this horizontally, right? And then you're going to stretch horizontally if you divide x by 3. Why is that? Because your x, so let's say this is the blue, right? X is equal to 1. At 1, this is 1. But now for the pink one, x is going to be 1/3. So at 1/3, it's like a smaller number. So it's going to like stretch towards horizontally. It's going to be thinner. Okay. And then if you multiply by 3, so for x is equal to 1, this would be 1. But for x is equal to 3, this is like much bigger. So if you multiply x by 3, it's going to behave. It's going to take this value at 1. So therefore, it is compressing horizontally, so it's getting kind of thicker. The body is getting thicker, okay, like that. All right, just give me 1 sec. Okay, so I think time is up. It is 12:51. Thanks for coming, guys. And we are on page, let's see what, I can't see it. Okay, stop sharing. Let me see. We are in 46, page 46. We're okay, we are going to continue like that. And I'm going to give you homework problems, but I want you to please register for my lab. I'm going to check how many students registered, and I'm going to start giving the homework. Thanks for listening. Do you have any questions?
Teacher, I haven't received the code yet. Please don't give any homework yet.
Okay, give them maybe today as well. You sent me an email, didn't you?
No, it wasn't me, but I'm waiting for the
Send me
code.
an email. When did you buy it? Did you buy on Friday?
No, I bought it on Sunday, yesterday.
Okay, give them 1 day. That's what they told me. Give them 1 day, and then they should send you the email, the code in the email. The reason I think it takes just 1 day because they're also handling the hard copies at the same time, and the hard copies take a little bit longer. So even if you don't buy the hard copy version, it just takes 1 day. That's what I understood from them. Okay, just give them 1 day, and tomorrow, if you don't get it tomorrow, email me and I will forward it to them. Okay, thank you.
Okay, thank you, teacher.
Any other questions I may answer before I leave? Okay, if no, then we can say bye. Take care, study hard. Okay, enjoy your time. It's Antalya Bilim University. Thank you. Bye-bye.